Hello friends, today's topic under discussion is bias, variance, overfitting and underfitting in machine learning. And these are the references I have used for preparing this topic. Machine learning and algorithmic perspective, machine learning by Tom Michel, data science design manual. So let us dig into this topic to understand overfitting, underfitting, bias and variance. Any machine learning, if it is performing poorly, it is either because of overfitting or underfitting the data. What is the goal of a good machine learning algorithm model? It has to generalize for the training data. From the training data to any other data from the problem down. So with this, what will happen is better predictions on the new data will occur. So in this regard, we need to understand how overfitting and underfitting are going to affect performance of a machine learning algorithm, because these are the two major causes of poor performance of machine learning algorithms: overfitting and underfitting. Let us look at overfitting. Okay. Now, as we mentioned, any machine learning algorithm model generalizing is the objective as it learns. So enough training has to be provided to the algorithm. What is the meaning of overfitting? Okay, you're using a data set to estimate the parameters of your model, but your model isn't that good at capturing reality beyond sample data. When the overfitting will be occurring? When a model tries too hard to achieve accurate performance on its training data. Why this happens? Because there are many parameters, so and less generalization happens, and maybe to avoid errors and outliers. What an overfit model does, it will be performing extremely well on training data, but less accurately on test data. Now, how do I try to avoid overfitting? Okay, you create new training instances by adding some random noise. Dimensional reduction is one technique. Let us say uh, maybe single value decomposition. It's a good way to reduce large feature vectors. So dimension reduction can lead to less overfitting and noise reduction. Let us go back to the meaning of overfitting again. If a model performs well on training data, that too very well on the training data, then overfitting happens. So when the model learns the detail and the noise in the training data to the extent that it negatively impacts the performance on the model on new data. This means that noise or random fluctuations in the training data is picked up and learned as concept by the model. So that will impact, because when they try to apply on the new data, they cannot be applied. Overfitting occurs for non-parametric and non-linear models. So say for example your decision tree. It is an example of non-parametric machine learning algorithm. Here overfitting is more. Now as far as decision tree is there, where overfitting is there, we can reduce overfitting by pruning a tree after the learning. As mentioned earlier, decision tree is a non-parametric, non-linear machine learning algorithm. So it means it has overfitting problem. But there can be techniques to avoid overfitting in decision trees. One approach is stop growing the tree earlier before it reaches the point where it perfectly classifies the training data. Second approach is allow the tree to overfit the data, then post prune the data. Related to overfitting and underfitting, we also need to understand a term called as cross validation. Now, when I say cross validation, I should recollect what is validation. Okay, say for example, any data set is there, and that data set will be used to train the model. Which model? Machine learning algorithm models. When the data set is there, the data set is split into training data, testing data, and validation data. Training data so that the model can learn well. Testing data so that the predictions can be done. Forecastings can be done, results can be formed. Validation data to check whether the performance is proper or not. Now, usually, if a data set is there, that data set, at least in our academic world, many of the students will be dividing the data set into 80%, 20%. Means 80% of training data and 20% of testing data. Usual suggestions in various literature is that you can do 50, 25, 25, like 50% training data, 25% testing data, 25% validation data, or even 60, 20, 20 also. That also is there. Now, when we are speaking about cross validation, we are speaking about evaluating the model, machine learning model. So, for evaluating the model, as I said, what happens is your data set is divided into training data set and testing data set, maybe a 80-20 division. Now, first what we'll be doing is we'll be fitting the model on the training set. Then what we'll be doing is we'll be finding out the mean square error on the test data and compare it with the training data. Okay, so if the mean square errors are nearly same, then our model has generalized well and is not in the danger of overfitting. So basically what we are doing, we are dividing our data set into training data set and testing data set. After that what we are doing, we are finding out the mean square error. After that what we are doing, we are comparing that mean square error of the training and the testing data. If the mean square errors are nearly same, it means our model has generalized well and it doesn't have the danger of overfitting. And whatever we did just now, that indicates cross validation. That indicates cross validation. Okay. Now, this is one way of evaluating the model. Here also again, these lines indicate how do I evaluate my machine learning algorithms so that I can restrict overfitting. Okay. One is resampling technique. The other one is hold back a validation data set. Okay. Now, when I say resampling technique, I am speaking about k-fold cross validation. And when I'm speaking about k-fold cross validation, I already know what is cross validation here. What is cross validation here? Finding out the mean square error of the testing data, comparing that with the training data. If the mean square errors are nearly same, then overfitting has not occurred. When I say k-fold, that number, so how many times I do the cross validation? Okay. It means k times I have to do this train and test subsets and then estimate. You can see here this graph, what it is indicating is overfitting example. So where if the matching of the predictions is very high, if the matching of the predictions is very high, so or very high, say for exact match like on the right side, then that is an overfitting problem. Okay, so this will lead to the model not able to generalize well, the model not being able to generalize well. Now you can see here, as I mentioned, any machine learning model it has to be first trained, then tested, then validated, then its performance will be checked kind of. So for this what we already mentioned was you are dividing your data set into training data set, testing data set, validation data set. Maybe as mentioned there 50, 25, 25, 60, 20, 20% division can be possible. Now, if you look at this diagram, what it is doing here is, this diagram indicates some technique called as leave some out multifold cross validation. Okay. With this, what we are doing, we are splitting the data into sets. Okay. And we are training a model on most sets and holding one out for validation and one for testing. You can see here you have many data sets for training, one for testing, one for validation. Again, you are changing this training data set. Again, you are keeping aside one validation and one testing. So this may help us understand the meaning of cross validation, the meaning of k-fold cross validation, the meaning of resampling, the meaning of holdback validation data set. Now coming to underfitting. Underfitting is a contrasting word to overfitting. What is overfitting? So the model has not generalized well. The model performed fantastically for the training data. So underfitting means the model neither performs well for the training data nor it performs well for the testing data. So it means it does not generalize both for the training and the testing data. So it means it is not a suitable model, and it means it will be giving a poor performance. So what is the way out? The way out is try some other machine learning algorithm, right? Now related to overfitting and underfitting, we also need to understand the words called as bias and variance, and as well we need to understand what is bias variance trade-off. So what is the objective of a supervised machine learning algorithm? The objective of a supervised machine learning algorithm is achieve low bias and low variance. Okay. So it will lead to what? It will lead to better prediction performance. Okay. But we need to understand what is bias and what is variance. Bias means it's an error. Why this error comes? Because of incorrect assumptions built into the model. So maybe we are restricting interpolating function to be linear instead of a high order curve. Okay. So when I have errors because of bias, they'll be producing underfit models. They do not fit the training data as tightly as possible. Bias are simplifying assumptions made by a model to make the target function easier to learn. Okay. Parametric algorithms have high bias, making them fast to learn and easier to understand, but generally less flexible. So if we have low bias, it suggests more assumptions about the form of a target function. If you have high bias, it suggests less assumptions about the form of the target functions. Low bias machine learning algorithms are decision tree algorithms, k nearest neighbors, vector machines. High bias machine learning algorithms include linear regression, linear discriminant analysis, and logistic regressions. Now we try to understand bias. Let us try to understand variance. Variance also is an error, but that is because of the sensitivity to fluctuations in the training set. Okay. So if my training set has measurement errors, sampling errors, this will lead to noise, which will lead to variance. Errors of variance result in overfitting models. Okay. So what is this? They try to be more accurate. Okay. And because of that, even noise is treated as appropriate data. Now, when you have high variance, you have high overfitting. Let us dig in more into what is variance and what is variance error. Basically, variance is the amount that the estimate of the target function will change if different training data sets were used. Okay. So same algorithm, same model is there, but I am changing the data sets. So, and there is a variance in the result. So, but the variance should not be too high, na? Even if I change the data set. If the variance is too high, it means something is wrong. Okay. So if you have high variance, uh, the reason for high variance is because of the specifics of the training data. Okay. Uh, it means the specifics have influenced the number and types of parameters used to characterize the mapping function. Low variance, it indicates small changes to the estimate of the target function which changes to the training data. High variance, it indicates large changes to the estimate of the target function. Non-parametric machine learning algorithms have a lot of flexibility, have a high bias. Decision trees have high bias. Low variance machine learning algorithm examples are linear regression, linear discriminant analysis, logistic regressions. High variance machine learning algorithm include decision trees, k nearest neighbors, and support vectors machines. Hope you are able to connect with these terms called as overfit, underfit, bias, and variance. Thank you.